Okay, hello everyone. I'm Andrew, and today, from last time, we just talked about what is AP Chem in general, and this time I want to go a bit more specific on this description, and I want to just go over all the units and the subunits that will be on the AP exam, and I want to go briefly, just talk about every subunit and give a brief description so you guys would at least know a glimpse of it before you guys would specifically go into it. And I will be skipping those specific details, but it's just a brief description of the course from last time. Okay, so the thing I'm showing you guys right now is the AP Chem course and exam description. So basically it's like this guideline of, so it's the guideline of what will come out in the AP exam, and things that are in the book all have a possibility of doing so. And if something's not in this book, then you can just know for sure that that's not going to be on the AP exam. So it's really important, and I really want to ask you guys to read this whole thing in your own time when you guys can, because it's just a great review overall. And before the test, using this book will be a great mode of review right before you take the test. Okay. So we'll be going over this book for the next few videos, and these are all relatively simple things that we could skip through. So these are the units and the weighting, but to be fair, you could see that some units are higher than others, but if we actually be honest, like they are all intertwined with each other, so you basically have to know everything, because if you don't know this unit, for example, then you can't solve some questions because this unit is directly connected to this question in an FRQ or an MCQ. So just know everything and don't like think about what is higher and lower on the exam weighting. So today I just wanted to go a bit more specific, where as you guys see, there's unit 1 and there's 1.1, 2, 3, 4, 5. Yeah, I just wanted to go over this and give a brief description. Okay, so first is unit 1, which is about atomic structure and properties. And these are the subunits. And so the first one is topic 1.1, which is moles and molar masses. So this unit is basically converting mass into moles and moles into mass, and just going back and forth. And I'll be reading you guys the objective. So the objective says to calculate quantities of a substance for its relative number of particles using dimensional analysis and the mole concept. So that's basically what you're doing. And the essential knowledge here that it's good to know is this Avogadro's number, which is like a constant that you always have to know when you're converting things into moles. But it's probably gonna be given to you in the formula sheet, so you don't have to memorize it, but you will eventually just do it as you guys solve questions. And the second one is mass spectroscopy of elements. So in my opinion, this is like the most free, like the most free part of the AP exam, because it basically just gives you a graph that's really easy to read. And if you guys just know how to read numbers, then you guys could determine, what has a higher percentage than others, and that could determine what's the more relative value. So as the objective states, explain the quantitative relationship between the mass spectrum of an element and the masses of the isotopes. So they basically give you this graph that talks about the frequencies of certain isotopes and certain masses, and your job is to differentiate what has the higher percentage, and that percentage is more like the one with the higher percentage is likely going to be the one that's that has the higher concentration, and that's going to be the major one that's composed. So to be more specific, it states that the mass spectrum containing an element can be used to determine the identity of isotopes, and the average atomic mass of an element can be estimated from the weighted average from the isotopic masses. So this is also important because if you guys look at the periodic table, for example, oxygen, it would say 15.999, but that doesn't mean that oxygen is always 15.999. It's just that the value is the average of all the oxygen isotopes, and that comes out to be 15.999. So 1.3 is elemental composition of pure substances. So as the objective states, Explain the quantitative relationship between the elemental composition by mass and the empirical formula of a pure substance. So what empirical formula is basically like the most simplified chemical formula as you could possibly go through. So for example, if you guys know glucose, you guys see it in biology and other places, is C6H12O6, right? But the thing is, with the numbers, there's C6, H12, and O6, and you know that those numbers could be actually be more simplified in terms of division. So they all have a common denominator, or which is going to be 6, and if you divided them all the numbers by 6, then it will be simplified into C1H2O2. So those are the empirical formulas where you make it much simpler as possible. And to be more specific on the essential knowledge, it's going to be about some pure substances are composed of individual molecules and others consist of atoms that are held together in fixed proportions. So that's going to be what empirical formula basically is, and I think everything else is relatively fine. Next is composition of mixtures. So this is pretty simple. I just have to read the objective for you guys, which states that the quantitative relationship between the elemental composition of mass and composition of a substance in a mixture. So how you do this is that you later would give in the moles and the percentages, and you basically just convert them into a certain ratio, and that would give you the percentages, but we'll go through that a bit more specific later on. Next is the atomic structure and electron configuration. In this part, you would be writing the electron configurations as you guys may have done during general chem and using the Aufbau principle. So some questions arise when it comes to this. So, there's this Pauli exclusion and Aufbau principle and those kind of things that you sort out to memorize in general chem. In AP Chem, you don't have to memorize this specific name called Aufbau principle, but the thing is you do have to know what it is, and maybe some FRQ questions or MCQ questions are going to ask about it. So I think it's pretty important. And some knowledges that you have to know are there. There's this Coulomb's law, but it's really, really important when it comes to these units. And later, there's this unit called intermolecular forces, where this also comes into play. But I think as of now, just know that this formula exists, and I'll be going through that later on. And the next is photoelectron spectroscopy. Okay, so this is I would say, the free questions in AP Chem, where first in the objective, it talks about the relationship between the photoelectron spectrums of an ion to find the electron configuration and the interactions. Okay, so what they're going to do is they're going to give you this graph, and what you have to do is you'll have to know the general number or the relative number of electrons, and you have to connect that to electron configurations to determine what atom it is. I'll be going through this more specific, but this is basically one of the most easiest thing. And this is shortened as PES, but in the FRQ, if you see a PES, just think that you'll get a free point. That's what it is. And the next is periodic trends. So you guys would have done this during general chem. And the objective says explain the relationship between trends and properties, and yeah, okay. So there's a lot of properties that follow based on which way the element goes in the periodic table. I'll be going through this more specific later on, but there's ionization energy, radius, affinity, electronegativity. Just to give a little spoiler, most of these, I guess, trends are similar in the fact that they go to the same direction, mostly through right top quarter towards fluorine, as ionization energy and electronegativity follows as its trend, but there are these reasons that you'll have to associate later on. And the next one is valence electrons and ionic compounds. So this says explain the relationship between trends and reactivity and elements and periodicity. And this is mostly probably about how elements in the same group and maybe in the same period would have a similar trait and a different trait based on how they move across the lines of the periodic table. So this is really connected to the periodic trends, as the reason of the periodic trends is directly from this trend of based on their periodicity. So this is unit 1. I'll be going through every unit in a while, and this is it for this video. Thank you.